Hello students, I am Dr. Amit Bhatnagar, working as Senior Search Officer in the Department of Agronomy at GB Pant, University of Agriculture and Technology, Pantnagar, Uttarakhand. And in the continuation of the series of watershed management lectures, we have discussed about the method to increase the soil moisture storage. Please watch this lecture and it is available in the playlist in watershed management. And there are two type of methods or measures we can categorize in two groups, biological measures and mechanical measures. So here I will explain the biological measures, what are the different type of biological measures and how these measures increase the soil water storage. Actually, biological measures are cultural practices or agronomic practices which increases the infiltration and percolation of rainwater into the soil. That's why water or the soil moisture increases and available to plant. So what are the those practices and how these practices work in increasing the soil moisture storage? So important biological measure or cultural practice is contour farming. So first of all, know what is contour. What is contour? Suppose a slope is there like that, a slope is there, then the line which are across the slope are known as slope, contour line, and these are imaginary line, these are not the actual line. Suppose you make a bund in like that direction, which are perpendicular to the slope, then these line or these bund are known as contour bund or contour lines. So this line is said to be contour. So contour are the imaginary line which are across the slope or 90-degree the slope. So it means this contour farming means contour cultivation practices, contour tillage, etc. For example, if we are going for a harrow, so run the harrow or do the harrow in this direction, because these are the contour line. So actually the slope is there. If we do the harrowing in that direction, it will increase the soil erosion and the soil storage capacity will decrease. Means if the soil erosion is there, topsoil is lost, then it will not hold the moisture. So this is contour farming or contour cultivation practices. So harrow should be done in this direction. Similarly, crops should be sown along the contour, So this is the way. Suppose one farmer is sowing the crop along the slope like that. The situation may be that if one farmer sow the crop in this way, means along the slope is in this direction, then after rainfall, during the rainfall, the water will move. This is the space for the runoff. So runoff water is there, and this runoff is according to slope. Run along the slope, then there will be wastage of water and will not infiltrate properly and percolate into the soil. But in this case, if it is along the contour, then this is the water, it faces the obstruction here, and now this faces the obstruction by the rows. So these are the different rows like that along the contour. This is our line, third line. So in every line, in every crop row, water faces the obstruction. So more time for infiltration and percolation. So this way of sowing is along the slope, which permit more runoff. So that's why more less entry of water, less infiltration, less percolation. Here in every row act as a physical obstruction, so more time for infiltration, percolation, and less quantity is wasted as a runoff. So this is the way. So contour farming means contour cultivation, contour tillage, contour harrowing, contour sowing. So this is very important practice and it should be adopted. If we do the practices along the slope, this is the slope direction, definitely there will be soil loss. So this is important measure which is known as contour farming. Another important biological measure is the strip cropping. In case of strip cropping, we make strips of the crop, two different nature of type of crop. Actually, there are some crop require frequent cultivation, intercultivation, earthing, hoeing, etc., like maize, sorghum, which are widely spaced crop. So widely spaced crop like maize or sugar cane or sorghum, we can say sorghum, sugar cane, which require 45, more than 45, 60, which require frequent cultivation. And some are closely spaced crop, where intercultivation is not done, hoeing is not done, like pulses, legumes, pulses. In general, not intercultivation done. For example, moong, urd, cowpea. So this widely spaced crop permit the erosion. This permit the erosion because we do some intercultivation. And these are closely spaced crop, so they resist the erosion. So they are a first densely grown crop and no intercultivation is done, so they are resistant to erosion or resist the erosion. Resist, we can say resist the erosion. Okay, so if we grow these crop in strip, suppose first strip is of erosion permitting crop like that. This is the widely spaced crop, 4 line, 5 line, 6 line, 8 line. Then erosion resisting crop, these are closely growing crop like that. Suppose these are the, suppose 10 lines, 20 lines, it may be 10 lines. These are the erosion permitting crop, widely spaced. And these are erosion resisting crop, ERC, these closely spaced crop. So if water runoff is there, so actually what runoff is there. So here there will be runoff, but here runoff will face obstruction. So in one part there will be runoff, but on the other part there will be more water entry, more water infiltration and percolation. So water remain in soil. So we can grow different type of crops. Okay, so if we are growing the widely spaced crop, so we should grow also the erosion resisting close growing crop, and this system is known as strip cropping. So this is the another biological measure, strip cropping, and strip cropping ratio may be 20:10, means 20 rows of erosion permitting crop and 20 erosion resisting crop, maybe 30:20, maybe 30:10. It is not the definite, but we have to make the strips of 10 line, 20 lines, 15 line. So this is another important biological measures. Now it would be clear how strip cropping increases infiltration and percolation. Actually, biological measures are aimed to increase the infiltration and percolation, and it is possible if runoff is reduced. So these practices, so this close growing crop reduce the velocity and amount of runoff. That's why more water infiltrate into the soil and percolate. So important biological measure. Then another biological measure is vegetative barriers. So vegetative barriers, these barriers are actually grasses which act as a physical obstruction to run off water. So these are the grasses, and these grasses are grown on the contour bund. Suppose this is slope, this is field slope. So we can imagine these are the contour lines, or we can make the bunds in that fashion. Then we can grow the crop, vegetative barriers, grasses on the bunds, 2 or 3 rows of grasses or shrubs, and these grasses may be used for the cattle, so it provides the fodder. So this is 2 or 3 row, but these grasses are grown on contour bunds. 2 or 3 rows of grasses, and these grasses can be used as a fodder. So very good grasses, panicum is used as a fodder crop. Then Napier grass can be used, and other grasses can be used which are perennial. So important one that these grasses should be perennial, so that longevity is maintained and provide the fodder for the livestock. Okay, then crops are grown in this between space. So here this space is used for growing of the crop. So crop is grown here. Now if running water is there, so this water, runoff water, suppose this is the runoff, then it face the obstruction by these vegetative barriers. So now water will obstructed, and then it will retain in the field and percolate deeper into layer and will increase the soil moisture storage. So these are the vegetative barriers, and these barriers actually are grown on contour lines. So that's why also known as contour vegetative barrier or CVB, and these are grown on contour bunds, and these bunds have grasses. That's why these are known as live bunds. So sometimes it is asked in examination, what is a live bund? So live bunds are contour bunds on which grasses are grown to intercept the runoff, so that soil moisture is increases. So it is very good biological measure to increase the soil moisture storage. Another important is the mulching. So different type of mulch are used, and actually organic mulch are used for increasing the soil moisture, not the plastic mulch. So mulch, organic mulch. Organic mulch act in different ways. Suppose this is a soil surface, and organic mulch is placed over here. Means residue, crop residue, etc. are maintained on the surface. Then first it intercept the kinetic energy of falling raindrop. So splash erosion is reduced. First thing. Second thing, it provide the obstruction to runoff. It prevent the runoff. Then these are the organic. So that's why they add organic matter into the soil, and this organic matter increases the porosity, and the porosity is increased, then infiltration and percolation is increased. So in the field, if mulch is maintained, crop residue is maintained, so this residue help in increasing infiltration and percolation. So that's why we should keep the soil covered with the mulch. Another mulch may be vertical mulch. Vertical mulch is used in those area where infiltration rate is low and runoff is high. So suppose this is the field, this is the particularly in vertisol where runoff is high and infiltration is low. Suppose this is the field slope is there, then trenches are made. Trenches are made at a distance, and then these are the deep trenches. Width is about 30 centimeter, depth 30 centimeter, 30 to 40 centimeter. To 30 to 40 centimeter is the width, and the depth is also 30 to 40 centimeter. So trenches are made first, then vegetative material is filled and put vertically put. So this is the trench, then vertically put, maybe grasses, shrubs, twigs. So vegetative material is put into the, and it is also above the soil surface. Above the soil surface. Shrubs, grasses, small twigs, leaves, etc. are filled, and it is also above the soil surface. If there is a runoff, then runoff is obstructed by this mulch, because this mulch is above the soil surface also and below the soil surface. trench is there, then water enter into the trench, and organic matter also help in entering the water because it is organic, so increase the porosity, then act as a physical barrier. So there is more water entry into the trench than in water infiltrate and percolate into deeper layer, and it is very good for recharge of groundwater or recharge the soil or the lower portion of soil. So it is very good method. Organic mulching in general and vertical mulch by making the trench and putting the vegetative material, particularly in those areas where runoff is high, infiltration is low and runoff is more. So to intercept the runoff, to cut the velocity, the kinetic energy, and trenches are made. It is important. Then organic material is filled, and the material is long, and that's why it put vertically. That's why it is known as vertical mulch. Another biological measure is tillage. Actually, these biological measures are aimed to increase the infiltration and percolation. So all those tillage practices which increase the infiltration and percolation and reduce the runoff, those practices, all tillage are biological measures. So there are different type of tillage. So important one tillage is deep summer plowing. In deep summer plowing, and this is practiced, first one it is deep, second one the season is summer. Deep means 25 to 30 centimeter. So in summer season, before the rainy season, the field is plowed and large clods are there. So if there is rainfall, then it is intercepted and infiltrate and percolate. Suppose the field is not plowed, the field is like that, and after the rainfall, runoff is there. After rainfall, runoff is there. Very little amount is infiltrated. For the infiltration percolation, soil should be exposed, porosity should be high, then water infiltrate. So deep summer plowing is very good method, and it should be practiced once in 3 years. Once in 3 years. It is not required every year. Once in 3 years, if we go for deep summer plowing, definitely water storage capacity of soil increases. Another example of tillage is the subsoiling. Subsoiling is breaking of hard pan which is developed at soil surface. Subsoiling. S-O-I-L-I-N-G. Subsoiling. So what is subsoiling? Actually, this is soil surface. So because of leaching of the materials, clay, etc., lime, etc., a hard layer is developed in subsurface, or due to heavy machinery. We are using continuous heavy machinery, maybe the reason, or the accumulation of the material. Then about deep, maybe 25 to 30 centimeter, a hard layer is developed, and this is known as pan layer or hard layer. Okay. Then water infiltrate, no problem, but water percolate, no problem, but after the 30 centimeter, water is not percolate deeper into. So that's why water storage capacity is up to this depth, while it should be up to the deeper depth. So here water accumulate and it create the waterlogging condition which is unsuitable for the crop. So it cause the harm. First one, it reduces the water storage capacity and it create the waterlogged condition, anaerobic condition, root development. There are many disadvantages of this hard pan. So breaking of this hard pan is must. So subsoiler or chisel plow is used to break this hard pan. So the subsoiler chisel is like that in this shape, and these are the tines, and these tines break this hard layer. So subsoiling should be done, and it should be done once in 3 to 5 years. So this is the important method. Then another tillage may be conservation tillage. In case of conservation tillage, our objective is actually to conserve the soil But now in biological measure, our objective is to infiltrate and percolate, and infiltration percolation increases with the tillage. But in conservation tillage, our practice is to reduce the tillage. So both are contradictory. On one side, we are talking about the deep summer plowing, where soil is exposed, but in conservation tillage, our idea is to minimum disturbance of soil. So how both are correlated? But conservation tillage are many type of tillage. So in case of conservation tillage, mulch tillage is very important, where tillage is done with the mulching. So mulch residues are maintained. So in conservation tillage, in general, 30% residues are maintained on the field. So mulch tillage is very important. So don't be confused. Actually, there are many soil conservation practices in which there is soil conservation, this conservation tillage. So in case of soil conservation methods, we try to conserve the soil. We check to wind erosion, water erosion, splash erosion, sheet erosion, gully erosion, ravine erosion, then wind erosion. And that's why we adopt so many practices, so that soil is not detached and transported in case of soil conservation measures. But here, in case of biological measures to water storage, our aim is to how to increase the entry of rainfall water into the soil, and how to increase the percolation, and how to recharge the groundwater. So that's why we have to change some other practices with the precaution that soil is not eroded. We have to conserve soil and water resources both. So that's why some tillage practices are very effective. Similarly, off-season tillage. Off-season tillage is very good practice, like harrow the field before the sowing of the crop, and then compartmental bunding. Suppose this is known as off-season tillage and compartmental bunding. Suppose this is the field, large field. Okay, so off-season tillage means suppose Kharif season start in June, then we should go the tillage before June, means in the month of April and May, means before the rainy season. Okay, so we go for the harrow. Suppose this is the harrowing, so soil is exposed. Soil is exposed. Now soil is exposed, then it is subjected to soil erosion. So precaution should be there. If soil has high erodibility, if it is subjected to high erosion, then we should not adopt such type of practice. We should be careful about the soil erosion. Our ultimate objective is to conserve the soil and water resources. So off-season tillage is practiced in the condition that there is no soil erosion. So that's why not deep harrow, small harrow, so that upper surface is exposed. Then bunds are made across the slope. Suppose this is a slope direction. This is the slope direction. Slope is in this direction. Then bunds are made in this direction. Field is divided and also in this direction. So different plots are there. This is known as compartmental bunding. Different compartments are there. So if there is a rainfall, so since upper surface is exposed, so rainfall infiltrated into the soil, and in each compartment it face a obstruction by the bund, so water retained in the compartment. Suppose rainfall is in this compartment, so soil is exposed, infiltrate, percolate, and remain in this compartment because it faces the obstruction from all the side by the bunds. So this is the off-season tillage and compartmental bunding. So there is good moisture, then we go for field preparation and sowing of the crop. So these are the some biological measures: contour farming, strip cropping. Then similarly we can go for cover cropping. Actually in cover cropping, the crops are grown, close growing crop which have dense canopy, deep root system, and they intercept the kinetic energy of the falling raindrop, and they add the organic matter. That's why porosity is maintained, aggregation is there, and then water holding capacity increases. So this is the way how we can increase the infiltration and percolation. And this infiltration percolation is related with the porosity, and which is inversely related with the bulk density. It means we have to increase the porosity. So another way to increase the porosity is the use of organics like FYM or compost. We use the FYM or compost, use of FYM or compost. or any other organic material. So these organic material add organic matter, and this organic material help in soil aggregation. Soil aggregation. And this soil aggregation is better because polysaccharides are released and some mucilage compounds are released, microbe population is more, and these microbes also secrete some compounds which help in soil aggregation. So whenever we add any organic, definitely soil aggregation is improved. So percolation is improved, soil physical properties are improved. So it has positive effect on percolation and infiltration. So this is another methods to increase the soil water storage. So strip cropping is very effective, cover cropping, tillage, particularly some tillage are very effective, deep summer ploughing, off-season tillage and compartmental bunding, and subsoiling, and the mulch tillage, particularly these are very effective. Then in case of mulching, normal surface mulching and vertical mulching. Vertical mulching, particularly in those soil where infiltration low and runoff is high. So to intercept the runoff. So don't be confused with the soil conservation measures where we adopt a number of practices like selection of crop or crop rotation or time of sowing. Different methods are there. So in soil conservation measures, our focus is how to prevent the soil detachment and soil transport. But in biological measures to increase the soil storage, our approach is how to make more entry of water into the soil and more percolation and recharge of groundwater. So overall thinking is same, philosophy is same, but the measures, biological measures and the soil, all these are also soil conservation measures. These are comes under soil conservation measures because they check the runoff. If runoff is checked, soil erosion is checked. But these are very specific to increase the soil moisture storage. So these are the different type of biological measures. Thank you very much.